Good morning, my dear students. I would like us to look at the solution to yesterday's assignment before we proceed on today's lesson. Um, I will not solve all the four questions based on those who have submitted their work. There is two outstanding questions that I need to explain: question 3 and question 4. None of the students were able to solve question 4. One student was not able to solve question 3. And question 1 and 2 was done perfectly by those who submitted assignment. So we shall look at question 3 and 4. Good. Now, question 3. Um, we're asked to find the coordinates of the points where the curve y is equal to x squared minus x minus 1 has a gradient of 2. Find the coordinates of the points of the curve y is equal to x squared minus x minus 1 where the gradient is equal to 2. As we all know, we'll differentiate the function y is equal to x squared minus x minus 1 to get a gradient function. So our gradient function dy dx is equal to 2x minus 1. At a point where the gradient is 2, our gradient function 2x minus 1 will be equal to 2. Then we solve for the value of x at that point. So making x the subject, we'll have 2x is equal to 2 plus 1. 2x is equal to 3. So we divide both sides by 2. That will mean the value of our x at the point where the gradient is 2 is 3 out of 2. We are supposed to look for a coordinate. So we have to look for the corresponding value for y. If x is equal to 3 over 2, what is the value for y? So we'll come and use the original equation. Y is equal to x squared minus x minus 1. Then we substitute in the values, the value of x. So 3 over 2 all square minus 3 over 2 minus 1. This becomes 9 over 4 minus 3 over 2 minus 1. Since we have ES calculator, we'll just punch this value on our ES calculator to find the value of y. Okay, so punching this on the calculator, we are going to have negative 1 over 4. This implies at the point where the gradient is equal to 2, the coordinate at that particular point is 3 over 2, 3 over 2, comma, negative 1 over 4. You should take note, most of you left your answers without putting them in the coordinate form. The question requires you to find the coordinate of the point. And coordinate of any particular point must always be in the form x, y in brackets. So don't leave your answers like this. Bring them back into this form. Okay. So that is question number 3. Those who could not solve question number 3. And those who could not even understand the lesson yesterday. That is that. Good. Good. Let's look at question number 4. Question number 4. We're supposed to find the equations of the tangent to the curve y is equal to 3x squared plus x minus 3 at the point where the curve cuts the x-axis. You have to find the equation of the tangent to the curve y is equal to 3x squared plus x minus 3 at the point where the curve cuts the x-axis. That is what most people could not understand. Let's look at something. I'm come to sketch a curve. So on our normal x and y axis. So this is my y axis. Sorry. My y-axis is here. This is my x-axis. Good. Then let's put a curve on top of this, an arbitrary curve. I'm just sketching any curve at all. Good. Okay, let me even use a different color. Let's use red. Okay. So good. Sketch an arbitrary curve. Good. So what the question is requiring us to find the equation of the gradient at the point where the curve cut the x-axis. So in this curve, if this is supposed to be the curve, then the question is demanding us to find the tangent at this point. This is a point where the curve touches the x-axis. It means you are going to have two tangents because the curve cuts the x-axis twice. So this is one tangent. This is another tangent. This is the point where the curve cut the x-axis. Good. So in effect, we're having two solutions, two equations. Now we need to identify the coordinates at the point where the curve cuts the x-axis. We need to identify the coordinate at the point where the curve cuts the x-axis. In JSS, when we were doing graph work, I know definitely your teachers must have mentioned what we call intercepts. I've mentioned what we call intercepts. Intercepts. There are two of them. We have the x-intercepts, s-intercepts, and then the y-intercepts. Intercepts are just points at which the graph will cut the axis. So with this, our curve that I drew, I'm drawing it again. A curve where the graph or the curve cut the x-axis is what we call the x-intercept. X-intercept. This is the x-axis and this is the y-axis. Where it cuts the y-axis is known as the y-intercept. So this is the y-intercept and this is the x-intercept. Another x-intercept is here. We learned from our JSS graph work that at the x-intercept, y is equal to 0. And at the y-intercept, x2 is equal to 0. So take note. So if we are supposed to find a coordinate at the point where the curve cut the x-axis, the coordinate at the point where the curve cut the x-axis, these two places, we should know automatically that the y coordinate is known at these two positions. The y coordinate here is 0 because it's an intercept of x. The y coordinate here is 0 because it's an intercept of x, and the y coordinate here is also 0 because it's an intercept of x. So what we need to obtain is to obtain the x coordinate at this particular point and the x coordinate at this particular point. Then we will now pair them. So it will be like our first x value. Okay? So this coordinate, first x answer to be x1, 0. Then the second s answer, s2, 0. So this will represent the coordinate here, and this will represent the coordinate there. Good. So let's now learn how to go and find the value for x at the two positions given. Let's look at how we can find the value of x at these two positions. Since we know that at the x-intercept, at x-intercept, y is equal to 0, we'll just substitute 0 into our equation. Remember, the equation is y is equal to 3x squared plus x minus 3. So when y is equal to 0, it becomes 0 is equal to 3x squared plus x minus 3. This becomes a quadratic equation. So we solve this using all the methods we know. Using all the methods we know. We can use the formula. We can also use factorization approach, or can we use completing the square? I'm going to just write the solution. Pause the video and solve and compare your answers. Let's look at the solution. I hope you have paused the video and you have solved to get your answers. So now compare yours with mine. As I said, there are so many ways you can solve quadratic equations. Well, this one, if you want to go by the what do you call it, the factorization approach, you need to multiply the coefficient here by the constant here. You will get -9. Then you look for numbers that their product will be -9, but their sum will be equal to the coefficient of the x here, which is 1. If you look through, there are no such pairs of numbers, and as such, the factorization approach cannot be used. So we have to use the formula. X by the formula will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. All over 2a, where our a is equal to 3, b is equal to -1, and +1, and c is equal to -3. So we substitute in our x will be equal to minus 1. So it becomes +1. But let me write that for the meantime. Plus, oh sorry, it is -1. The b is +1, so it is -1 minus or plus the square root of 1 square minus 4 multiplying 3 multiplying -3 all over 2 multiplying a, which is 3. Good. So this becomes -1 plus or minus 1 plus we shall have 4 multiplying 4 times -9, so it becomes -36, but because here is already plus a minus, when here becomes -36, it will affect this place. We are going to have +36, so +36 all over 2 times 6, and that 2 times 3, and that will give us 6. So we are going to have -1 plus or minus the square root of 37 over 6. So your first x answer, which we'll call the x1, our first x answer, which we shall call the x1, will make here plus. So let me point on my calculator. -1 plus the square root of 37 all over 6. Good. We are getting 0.84. Our first answer, -1 plus square root of 37 all over 6. That is giving us 0.84 blah 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 0.84. So let's break it to decimal place, 85. Then our second S answer, x2 will make it minus, because that somewhere there is plus or minus. So this time we have done the plus. So minus 37 all over minus square root of 37 all over 6. So let's use a calculator, and that is giving us -1.18, -1.18.180 blah 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 to 2 decimal places. So it means the coordinate at which the line cut the x-axis is 0.85, 0. That's one coordinate. And the other coordinate, -1.18, 0. So these are the two coordinates where the graph cut the x-axis. So we are now going to use this to find the equation at these two positions. So let me write this somewhere because I want to clean the board and continue. 0.85 and then -1.18. Okay, so now I can clear my screen and then proceed. Okay, so let's proceed. Hope you are following. Now, these are the points that we got. I've just cleared the screen so that we can get space. These are the 2 points that we had from the previous calculation. So we are proceeding from that point. So let's continue. In order to find the equation of the gradient, equation of the tangent at this place or at this point, we need to obtain the gradient first. And to obtain the gradient, we need to find the gradient function. So the gradient function is dy dx, and that will give us 6x plus 1. So let's deal with this one first. Find the equation at this point. So to find the equation at that point, we'll find the gradient there. So we just substitute in the x, which is 0.85. Good. And we'll find the gradient. So let's check from the calculator. 6 times 0.85. 6 times 0.85 is 5.1. So that's the gradient. Now we will use the gradient formula, the equation of the line formula. Y minus y1 is equal to m x minus x1. Putting in mind, this is our x1, this is our y1. So we have y minus 0 is equal to 5.1 for the gradient, and x minus 0.85. Then this becomes just y, because anything 0 minus 1 minus anything minus 0 is the same thing. So open the bracket, we have 5.1x. Then 5.1 multiplied by 0.85. 0.85 becomes 4.34 to 2 decimal place. 4.34. So that's the equation at this point. Equation of the tangent at this point. Then let's find the equation of the tangent at this particular point. Negative 1.180. We know our gradient function already. Our gradient function, which is dy dx, is equal to 6x plus 1. So at this point, our x value is minus 1.18. So the gradient there, let's look at it. Product 6 times negative 1.18 to give us minus 7.08. Good. So that's the gradient. We are using the same formula y minus y1 is equal to x minus x1. Knowing that this is our x1, this is our y1 in this scenario. So our y is still 0, negative 7.08. Then x minus to become plus 1.18. So y will be equal to minus 7.08 x plus multiply 7.08 times 1.18. 1.18, that is, oh sorry, this will become minus, so minus 8.35, 2 decimal place, 8.35. Good. So this question, I want to go over again. Note that if the intercept, the x-intercept, that's what you should know. As x-intercept, the value of y is always 0. And then at the y-intercepts, the value of x is also 0. So put in mind, so in another scenario, you may be required to find maybe the coordinate or the equation of the tangent where the curve cut the x-axis, or another scenario, maybe the y-axis. So take note of these concepts. At each of the intercept, the other coordinate line has a value of 0. So if it is an x-intercept, then the y coordinate should be 0. And if you are the y-intercept, the x coordinate should be 0. So that is one concept you should know. Do not forget. Thank you very much. I'll be uploading the second video for our lesson for today. So having watched the solution, we want to watch our lesson for today and do the assignment there. Our lesson for today will be curve sketching, how to sketch curves. See you in the next video.